Oh, we can basically get it started, and hopefully more people are going to join over the course of presentation. So thank you again for attending the third session of our monthly webinar series with the theme of generative AI. In the previous session, we presented a practical application of the research agent that uses both an internal knowledge repository as well as external resources like internet search to answer to the user query. This session will explore another interesting application of AI agents, this time in the field of engineering. We will demo a use case where once the user submit the query, the AI agent parse a pipeline design guideline and find a specific section of the guideline to address the question, and then return a cohesive answer using that section of the guideline again to answer to the user query. It can also go one step further, and not only it effectively retrieves that section of the design guideline, it can also basically map that part of the guideline to a specific set of tools that we have already defined, and we made it available for the agent, and execute those tools to calculate if there's an equation in that section or what the user asks. For instance, if the user asks for calculating the internal pressure, it will go and find the tool for calculating the internal pressure, and then get the result, and at the end come up with the coherent and final answer and return it to the user aligned with the references and all the intermediate steps. So as for a brief introduction to Arcurve, which hosts these monthly webinars, founded in 2006, Arcurve is a full-service technology, advisory, and software development company. It guides organizations across different industries on their data journey, helping them leverage technologies to enable data-driven decision-making capabilities within their organization. So with that introduction, let's now do a quick overview of the bio. This session will be presented by my colleague, Mike Morley, and myself. As for my bio, I'm currently a lead data scientist at Arcurve at the Advanced Analytics Group. I've been with Arcurve for more than 2 years now. By education, I hold a PhD in civil engineering from Memorial University of Newfoundland. My research was focused on the stress analysis of subsea pipelines under moving loads. So this particular application that we want to go through, I'm to some extent familiar with the stress analysis of especially buried pipelines. On industry, I have more than 6 years of experience in different fields. I have built and operationalized machine learning models, and more recently focusing on building applications using large language models and generative AI. I've done a lot of final element analysis and pipeline stress analysis. I worked at Technical FMC at the Advanced Analytics Group, and then for my postdoc, we moved to Calgary, and I did my postdoc there, and then I pivoted to tech, where I started working at AltaML, and then I've been working at Arcurve, as I said, for more than 2 years. In my free time, I enjoy playing ping pong, mountain climbing, traveling, making, and primarily eating sushi. So pass it to you, Mike.
Thanks. Yes, I also come out of an engineering background originally, and have kind of worked in the interface, I would say, between technology and engineering throughout the course of my career in environmental, finance, AEC, mining, and energy sectors. Couple of notable kind of neat things. I actually helped to develop a three-dimensional mine modeling blast simulation system kind of in university and afterwards, which was a pretty amazing experience. I worked at Matrix Solutions, helped set up the IT software functions and the inside of that organization, which enabled it to grow from the 40 some odd people it was when I started there to about 800 people. some insights inside of the context of the complexity of data in the environmental domain led myself to and another Jeremy Blay to found a company called Menome Technologies in 2016. We were focused on simplifying complex data and turning that into actionable insights. And that company was acquired by Arcurve a number of years ago now, 5 years ago. Wow, amazing. And these days I help advise enterprises and speak on the subject of AI. Mountains also, yeah, big thing, mountain biking. I currently play music in my daughter's band, so check out Tori Morley if you're into music stuff. And I do improv as well as a fun sort of hobby. Yeah.
Nice. Thank you, Mike. So as for the agenda of this presentation, the first part would be just setting up the foundation, and we will start by discussing the business challenges that enterprises face, as well as the benefits they can gain from leveraging AI agents. And next, we will briefly introduce a specific type of AI agent that's called React agent. For those of you that have been following along in the previous sessions, it would be just a quick reminder for you, and we won't go into the details. So, and finally, we will showcase the design agent, which is an advanced application of a React agent in pipeline engineering. So now I hand it over to you, Mike, to discuss the business case for agentic AI.
And the demo that Farhad's going to show you is pretty impressive, so make sure you stick around for that. And yes, it does actually use some RAG aspects, so Farhad will explain all of that. But first, I want to talk a little bit about why we're so excited about this whole thing, both Farhad and myself and the folks at Arcurve. And it gets into this notion of the way that agentic AI helps address complexity. There's been anybody who kind of works in this domain, or even some people who just basically have to work with computers or even mobile devices, your phone these days. These systems have become very, very complicated. I know on my phone I have more than 100 apps on it that I have for doing different things. Even simple tasks like trying to get your banking data out of your bank and into Excel or into a budgeting software, or over to the folks who kind of handle your taxes and whatnot. That's a pretty complicated process. Finding data for a month-end report for a VP involves having to go around to a bunch of different systems, pull the data out of them, try and compile it together, and then massaging it somewhat, or answering a question from a client using data from your various systems that your company has. All of these things are pretty involved processes, and it gets down to the fact that it's because machines can't easily interpret human commands and human-centric data. There's a process associated with people having to translate the intent, the things that we want the machines to do, into a form that machines can understand. And if we go to the next slide here, there was another transition where we went from a complicated means of interacting with computers to a simpler one back in the 1980s. And this was when we shifted from the command line interface back when I started in computing with things like the PCs when they first showed up on the scene. You had to write programs and know system commands that you'd feed to the machines to get them to do things. So that involved learning a lot of stuff and understanding a lot of Byzantine commands and assembler in some cases and this sort of thing. That was then supplanted by an innovation called the desktop metaphor. And that was largely made, brought into the public consciousness by, of course, Apple Macintosh in 1984, and later expanded through Windows. If we go to the next slide, that innovation actually started a number of years earlier with the Alto in 1972. And back at that time, the computing was pretty limited. Anybody who's had the opportunity to work with one of those older machines, the desktop metaphor was pretty revolutionary, but it was really simple. And it was because of the fact that the machine intelligence at that time was pretty basic. So that required the folks who were designing these interfaces to, come up with some pretty simple metaphors for allowing people to communicate their intent about what they wanted to do to the machines. And this is where this idea of windows and mice and icons came from. It's the idea that, hey, I want to draw a picture. So I click on the little picture drawing icon that launches the application, tells the machine to launch the application that draws the pictures. Inside of that thing, you have a paintbrush, which then is actually, as you draw on the screen, it's providing instructions to the machine about how to open that command and the way it's interpreting the user's interactions from the mouse and so on. This was a big innovation at the time. But while all of the, the machines that we work with now are much more sophisticated in terms of their compute power, in terms of the fact they can, render complex 3D objects and do all sorts of amazing things, the basic way that we give machines instructions about what we want them to do has not really changed that much. OS X in 2024, if you were to fire up a version of the old Alto thing in a virtualized environment, you'd see and you'd be able to work with it right away because it's very, very familiar. It's really slow, but it would still work the same basic way that OS X or Windows it does today. Next, and if you look at the next slide here, the challenge with this, though, is that because we haven't really, the way that we work with the machines, the way we tell them what we want them to do hasn't really changed much. This has caused an explosion of applications or apps, as they're more commonly known these days. My computer here, I've got 4 monitors. I've got 6 desktops that I work with, each one kind of set up with the context associated with the different projects that I work on and whatnot. As it moved to the next slide. And so just to get my job done on a daily basis, I have to interact with a whole pile of different systems and whatnot to get that to happen. And from this Harvard Business Review study that I found, typical people, a single supply chain interaction on a daily basis, a person is switching 350 times between 22 different unique applications and websites to get that job done. That means a single employee is toggling between apps and windows about 3,600 times a day. That's just crazy when you think about it. Hours and hours of toggling back and forth. If we go to the next slide, the compounding this challenge is the fact that we've got this proliferation of clouds and software as a service type systems. And the commercial aspects start to play into this a little bit, compounding the limited user interface metaphors we typically are working with to translate human intent into machine commands. You're also dealing with different companies who make these systems now and different domains. So you have Salesforce being one example that, that basically has made a system for customer relationship management. You then may be interacting with Microsoft Dynamics, handling the financial aspects of the company's financial data and whatnot, and maybe Dell Tech for the project management pieces. If you're a person who needs to get a report done for a VP using the data from these 3 systems, you need to go into Salesforce. You need to understand how Salesforce models and represents the world of the data that it manages for the customers. You need to understand the way the metaphors that they use the icons inside of that system. You need to understand the commands to work with them. The interesting thing, of course, is that Dell Tech will have a different way of modeling, even though it's got customers in it, and Microsoft Dynamics has customers in it. Each one of those systems will have a different set of metaphors, a different set of patterns for modeling and managing that same customer. They may even have the same icons, which have different meanings in those systems. So just trying to get data out of these things to answer a question becomes an incredibly complicated process. And the average company has 254 software as a service type apps that people are interacting with on a daily basis. And then if we go to the next slide, you also have on top of that, or maybe underneath that, the aspect of the data piece. Typical data sources to set up a business intelligence report, and Arcurve, we do a lot of work in this world as well, helping organizations bring data together to answer questions, to create dashboards, all this sort of thing. It is actually a fairly involved process to do this. companies draw from 400 different types of data sources to feed into a typical dashboard. It's not unusual for that. So somebody who's trying to, answer a question for a VP or to create a report for a client or even pull together engineering data to do a study, any of these sorts of things becomes quite a task. And again, it gets back to this idea that we're increasingly being forced to work the way the machines want us to, as opposed to the machines working the way we want them to, by explaining our intent to them and having them go out and handle all of this complexity for us. We end up being the agents in these very, very complicated workflow systems. And this has gotten to the point of where, 38 from the study that was done that's cited here, 38% people who are working in these types of average enterprise report that manual coding of data pipelines is a major obstacle to them doing their work. 32% of folks said that they were having trouble just even connecting to multiple data sources. And you can certainly understand why this is the case. Each system has its own user interface. It may have its own way of exporting data. Companies often don't like you moving data back and forth between their systems. They want you to stay in their world. So while they may provide an application programmer interface, then you have to learn how that thing works and all the nuances of it. It may be in JSON, another one may be in XML, some other thing may be in ODBC. A person, trying to get data out of these things has to learn a lot of stuff before they can actually do that. Which, if we go to the next slide, to Alan Kay's point, Alan Kay, if you haven't read some of his stuff, it's worth reading. He's got a lot of really amazing insights into this world. Is it really complicated, or is it really complex, or did we just make it that way? Business processes have become incredibly complicated. Even doing something as simple as trying to book a vacation. You have to go into an HR system. You have to find the form for the vacation booking. You have to fill that out. Often these things don't have your data in there. You have to, manually transcribe it across. That gets submitted into some workflow process that may go to some, a number of different managers inside of that. Then the person will have to go into Outlook, block their calendar off, make sure that those days that they in their calendar are taken care of, so folks don't book meetings for them and whatnot. They probably then have to go into a system like Deltek or Dynamics to let the teams that they work with know that they're going to be out and that there are other people who can take over parts of their job, and so on and so on. Now imagine if you just had an agent that had a bunch of tools in place that could talk to those specific systems. So you developers go in, they would create these little tools that could handle the different interaction pieces. And then you have an agent that's conditioned to take requests about a vacation. And all the person would have to do is say, I want to go away from November, the last 2 weeks of November. The agent would then take that information. It would figure out, it would understand the nature of the request. It would then figure out which tools it needs to use to accomplish that objective on behalf of the user. It would go and execute those commands. It would then report back to the user as to the state of the process that is done. And this, if we go to the next slide, is kind of the crux of the whole thing here, where we are moving from a paradigm in which limited machine intelligence forces people to interface with the machine. So we have become the agents in these multi-agent systems. We are the ones going around doing all of this work to try and get these computers to do what we want them to do. And it's because the machines don't understand. When we ask them a question, they don't understand how to execute the steps needed to formulate that response. They don't know which systems they need to go into to book a vacation, to submit an expense report. Programmers and developers have had to sit down and write out all of these instructions in a very sort of tedious manner. And as we know, business processes change all the time. So not only is it hard to write these things out to start off with, these workflows, it's also difficult to maintain them because they change all the time. Instead of this, if we go to the next slide, what this agentic AI stuff does is it allows us to have users to have a simple interaction with the machines, and then the AI translate the human instructions to machines instructions. This is the crux of this innovation. It's this ability of the artificial intelligence harnessing partially large language models, but combining it with the deterministic elements, the useful parts of the workflow processing paradigm, in which you have this overarching agent that basically can be conditioned to take the user's request, take the parameters out of it, transform that into a strategy for moving forward with the request. It has access to a set of tools that it has been given. And then each of these tools can have also smaller agents in them that can respond to shifting conditions. So if something happens to change in the context of the way a vacation needs to be booked, the form shifts around a bit or something, these types of agents can actually figure this sort of thing out and adjust accordingly without having to be reprogrammed all the time. So if we go to the next slide, what this lets us do is this paradigm shift from deterministic workflows and deterministic agents in which people are the ones kind of doing all this transcription and translation, is the AI agents are going to provide us a new way of interfacing with machines. Because AI agents empower machines to interpret human instructions. And the impact of this is that user interfaces are going to become a lot more flexible and fluid in terms of the way they can handle people's requests coming into them. And they're also going to be able to understand and map out sequences of steps to then move forward with requests from people. And if we go to the next slide, this then enables us to do things like answering enterprise questions through Agentic AI. Because the agents can generate paths to achieve an objective, they can, if you give them a set of tools to work with, they can determine which tools they need to use. So if you can imagine having a suite of tools across the enterprise that are all kind of there in terms of interfacing with HR systems, interfacing with things like Deltek Vision, interfacing with Microsoft Dynamics, and so on. And then having an agent, a vacation booking agent, an agent that does that can handle figuring out financial reporting for third quarter type requests, these sorts of things. The user can provide that request to these agents. The agent will figure out the path to which it needs, the steps it needs to do to use the tools to get that request done. It will go execute those things and then report back to the user. And if we go to my last slide here, this enables this notion of what we call AI knowledge workflows. So using large language technology to harness knowledge from across different system boundaries to answer questions that project stakeholders may have, that external stakeholders may have about projects. Health and safety reporting is another example that we've been we're looking at for a number of for a couple of clients. This is a really interesting one because I built a number of hazard ID related systems over the years in the environmental companies and other places I've worked and whatnot. Health and safety data is really interesting because it's partially deterministic, but also unstructured. So just using a simple example, hey, if there's a pile of bear scat that I've spotted in the field where I'm working, you send that back in. Normally what you'd have to do is write a bunch of, as a programmer, you'd have to write a bunch of logic or have a special form written that the person would fill in to send this stuff in to the HR team who can then notify other people in the field about the fact there may be a bear in their area. With this sort of AI technology, the person could either take a picture of the bear scat and the AI could figure out what that was and then take steps from there to alert people who are kind of working in the same area that this person is. Or the person could just talk to their phone. Hey, I see some bear scat. And of course, the AI would then determine that's a hazard. It would alert people accordingly and so on. And then, of course, the example that Farhad's going to show you here now, harnessing knowledge and regulatory documents to drive agentic AI tools for use in design processes. This is a pretty impressive example. So I'm going to turn it over to you now. So less talk and more action, shall we say.
Thank you very much, Mike. So that was a fantastic foundation for what I'm going to present in the next few slides. I see a few questions on the chat, but basically, I think it would be easier to answer those questions at the end because some of them are a little bit, especially like one at least is technical. So it would be answered by these slides. So if you don't mind, please wait. Yeah, thank you. Okay, in basically in the next few slides, we will explore an application, a particular application for a specific AI agent that's known for React agent, which stands for reasoning and acting. So the React agent workflow is an effective approach for streamlining the business process while maintaining transparency and accountability, which are the key challenges when implementing Gen AI at the enterprise level. So, but what does it mean? What does reasoning and acting mean? So reasoning involves breaking down a problem into smaller pieces and using a chain of thought to address each part in a sequential format. For instance, if the goal is to move from point A to point B, you can also see that in the flow. On the slide, the agent first identifies the path from A to B, and then B to C, and finally C to D, tackling each segment individually and feeding the result into the subsequent step. A key aspect of the reasoning is that each part of the problem, or like each specific segment of the whole problem, is mapped to a specific predefined tool or function. So as you can see in this flow, for instance, A to B is being mapped to tool 2, B to C to tool 3, and C to D to tool 4. And basically, the mapping of each segment of the problem to a particular tool is something that's called function calling. And this is the inherent capability of the most modern large language models, that they have it built in. And this is what Mike was talking about when he was talking about like the agent can manage different tools instead of we become an agent and try to manage them. So this is an agent who knows that for this part of the problem, it can call that a specific tool. But not only that, it can go a little bit further. And for instance, if the first part of the problem basically map that to this specific tool, but that tool like needs more information, and this part of the problem or this part of the user query doesn't satisfy all that. So in a typical workflow, it's going to throw an error, but the agent can handle that. The agent can assume some variables or arguments or some logics and just smoothen out these interaction between the tools. And that's what we're gonna also showcase in the live demo that's coming next. But having all there by mapping, this is where we get to the acting part, because if you recall, so the React is the reasoning and acting. So the acting component of the React agent is after the mapping, and that's where we execute these tools. And so we execute them, and these are the tools that we have defined for the agent. These are and this basically make the whole process pretty transparent because we have the full control over the tools. And then once the tools are executed, the result is fed into the next step. For instance, the result of tool 2 would be the prompt into BC, and then it goes forward. And once all the steps has been tackled and has been addressed, then the agent has a memory and has access to all the information that's been accumulated, and can basically consolidate them and come up with a coherent answer to the original user query with all the reasoning and intermediate steps that could be provided and returned. So again, this approach adds significant transparency to the process because unlike directly using Gen AI, which is a black box, we break down the problem into manageable parts. And so again, we use the tools that we have defined. So that's also another layer of transparency. So last slide before getting into more details about the demo. And I know that we have gone through that in the previous session, but a little bit more overview and introduction to what are the unique features of React Agent? What makes an agent actually? So agents are nothing more than the large language model with some unique characteristics and mainly a set of instructions that we have provided for them. As for the React agent, some of the main characteristics are first the system prompt. So for those of you that you're not familiar with system prompt is a set of instruction that remains constant throughout the interaction with the large language model. For instance, let's say that you are asking a bunch of questions and then you want the large language model, when generating an answer, it follows specific format. That's where you can provide the instruction. For instance, you can provide the persona for the large language model. You want it to be a pipeline engineer, or you want to provide a set of examples so that you provide in-context learning for the LLM, so that when it answers to you, you expose it to some of the information that it's not been trained on. So that's called in-context learning. So that's where system prompt comes into play. And then we need memory, because if you recall, the reasoning part of the React agent means that it breaks down the problem into smaller pieces. And once it solves each piece, it needs to consolidate and it needs to accumulate all the answers and consolidate them together, and then basically return the final answer to the user. And that's why you need the memory. You need the memory to have access to what was going on in the previous step. And also you need the toolbox. You need a set of tools that we define and we make it available for the agent. So these tools could be a set of Python functions. For instance, it could be a particular equation in the design guideline, or it could be an API endpoint, or it could be like an Abacus FEA software that you can basically trigger based on a function in Python. So all that could be defined as a tool, or like one of the attendees mentioned, it could be a RAG. So RAG could be a tool that's been introduced to the agent to use. And finally, in order to be able to switch between the steps and basically execute them sequentially up to the end, we need a looping logic so that it goes from A and get to D if D is going to be the last. So, and with all these characteristics, we can build a React agent from scratch. So in the first session of this webinar series, we had a session specifically discussing how to develop a React agent from scratch. And we also provided the source code, which is public. So feel free to go to the YouTube channel of Arcurve and check that out. So you will see how to build a React agent without using any libraries from scratch, and it basically follows this workflow. And in this workflow, I'm not going to get into more details, but I just want to show you like these components that I mentioned. So first, there is a system prompt, which is going to be a part of memory. And then there we have this flow, which is effectively a function calling. What this flow does, it does the mapping between the subproblem and the tool, the corresponding tool. So it does the mapping and it does the execution of the tool, and it generates the observation, which then will be stored into the memory. And then we have this looping mechanism so that it goes until it gets to the points that it needs no further action, and it can answer to the final, it can basically answer to the original query, and that's where it returns it to the user. So great. With this introduction, now we want to get into the source code and finally the live demo. So as for the source code, basically, I just want to show you how to get into the source code. So simply go to my GitHub. So github.com/davarpur. That's where you can find the repo. And so it's already pinned in here, but you can also go to the repository, and that would be the first repo, generated application in Python engineering. And in here, you can have access to all the source codes, and you can clone them, and you can run them locally on your system. So I'm going to provide a little bit of explanation about the source code and about the README, so you can just feel free just to go through them after this presentation, but I'm going to do that now anyway. So basically, this live demo, what we're going to do, we are going to use the American Lifelong Alliance 2005, the design guideline of the buried state pipeline. And we are going to use that so for our RAG system. And when the user asks a question about this guideline, the agent basically has access to the RAG tool, and it can leverage the RAG tool in order to parse through the guideline and find the specific section that addresses the question and return it to the user. So again, so in addition to that, you can also execute some functions that we'll go through later. But beforehand, I'm going to just show you about these guidelines. So this is the American Lifeline Alliance, basically 2005. And for instance, we can ask a question just randomly about like the pipe wall stiffness, and it's supposed to return this particular equation and provide information about where the information is coming from, so that it's transparent and we have access to the source and where the information is being retrieved. And in addition to that, as we talked, it can also go one step further, and it can also execute a tool corresponding to this equation. Again, it's not going to use its trained data in order to run that. It's going to map this section of the design guideline to a specific tool that we have already defined, and then it's going to execute that tool in order to calculate, for instance, the pipe wall stiffness. And that's what we are going to show. So this basically, in this demo, we're going to show just one simple example, but that basically show the capabilities that we went through in this presentation. Another important thing that I need to mention is that in terms of, is it legal to use the ALA material in basically in this application? So effectively, in order to be able to use that, we should get permission from the ALA. But again, if we go there, we see that this is publicly accessible. So I mean, this is just, if you go to this website, you have access to the PDF. And in terms of permission, you will see that it allows content copying for accessibility. Still, it's a little bit of gray area because it says like content copying is not allowed, but content copying for accessibility is allowed. And the technology that I'm going to showcase most likely fall under this. However, I did my due diligence. I tried to communicate with them. There are 2 emails on the website. None of them worked. And I provided that in the repo so that if somebody from ALA just contact me and reach out to me and want me to put it down, so I will put it down. And this is solely used for educational purpose. So I needed that to be recorded as a part of this presentation so that you guys that you want to leverage this, you also become familiar with the licensing of using these demo. But the main goal in here is not just to use this app in any production level application or for any use. This is just to show the capabilities. And then if we want to use that, so that would be the next step, because this is a very simple implementation of these React agentic workflow. Okay, and another piece before getting into the live demo would be just to show you what it means to build a tool, because we keep talking about building a tool, and this is where we define the tool. But this would be a better place to show that. So this is the app.py. That's where you can check it out if you are following the line. And the first part is the setup, and then you will see that there's a part that we introduced the first tool. What is the first tool? As I mentioned, we have RAG as a first tool, and this is the part that we introduce a RAG, which is connected to, basically it has the ALA pipeline design guideline already indexed, and it has access to that, and it can basically do the retrieval augmented generation against that design guideline. And we have some description for this tool, and that's how React Agent identifies when it has to map that particular part of the query to this tool. For instance, you can have different guidelines. You can have 10 or 20 or hundreds of guidelines in here, and each one of them could be defined as a tool. And then your React agent, based on the description in here, would know when to use which one of these tools. And in addition to that, I've also provided one additional tool, which is to calculate the axial soil force. This is the maximum axial force that's been imposed on a berry pipeline per unit length. And again, this is the description in here. And that's how the React agent can figure out when to use this tool. And finally, like once we introduce all the tools, so we typically introduce them in a separate file, as I've showed you. So under the source, under the tools, you will see that, for instance, we can define the calculate axial soil force. There's a little bit of data string, and then this is the equation that's coming directly from ALA design guideline. So you can basically, for each one of the equations, for anything that you want your agent to be able to execute, you can define a tool. But this tool could be Abacus. I mean, it could be an FEA like simulator or anything else. And you need somehow to define a function so that the agent can use in order to get connected to that tool. So getting back here, once we have defined all that tools, the next step will be to introduce those tools to the React agent. And in here, we are using Llama Index. And so what Llama Index does, it does some of the abstraction for us, if you remember. So we have the looping logic, and we have the system problem. We have a little bit of the steps that they are streamlined using packages like LangChain or Llama Index. In this case, I'm using Llama Index, and this React agent is directly coming from Llama Index package. And then like these are the two tools I'm introducing to the agent. I'm also updating the prompt, the system prompt, based on what I want the React agent to do, because I need it to do a specific thing and to be basically updated to be a design agent. So that's where I need to update that. And the rest of that is just some UI configuration. So let's be back on the main page. And once you are here, you can click on the opening Streamlit. And then you can basically see the live, basically the demo. This demo has been deployed on a Streamlit. And there is one interesting thing that I wanted to mention. You see that there are two models in here, GPT-4o1 preview. I mean, it could also add the Claude like Sonnet 3.5 or any other models. One very interesting thing and opportunity for enterprises is that once you build your agentic workflow, as we move forward, and we will have more advancements in the Gen AI space, and there's going to be smarter models. Like, for instance, we have O1 preview, but O1 is much smarter than O1 preview based on the article that OpenAI released. So as we move forward, the agentic workflow doesn't need to be updated. But because the LLMs are going to be smarter, so the whole system is going to be significantly smarter. So you don't need to change anything. You just need to change your model type. And that's the advantage of like building your workflow now, and you don't need to wait for seeing what will happen in the future. What is certain is that we are going to the era when we need these agentic workflows. But as we move forward, they get smarter. How? Because we are going to have smarter models. So for now, I'm going to use like the O1 preview, which is the state of the art, and in the leaderboard, this is in terms of so many performance metrics, that's the smartest. There's a little bit of explanation, like what we discussed, the guideline it's using. And for this particular live demo, we are going to ask these questions because these are the tools that I've already defined. But I can basically define all the tools that I want, and then I can ask any question, and it's able to answer them. Still, it's able to answer most of the questions because it has a RAG. But in terms of executing a particular equation, I've only defined the axial force on the berries pipeline. So here's a question: how to calculate the maximum axial soil spring force on a buried pipeline? And in here, I'm specifically asking to use the ALA design guideline. This basically, help the agents to make sure which tools to use. And then we are also specifically asking the agent to calculate the maximum axial soil force, and we provide a bunch of variables. But what we are going to test in here, so a few things. First, we wanted to make sure that it can split the problem into two pieces, because there are obviously two pieces. This is not just one problem. There are two problems. Second, we want to make sure that basically can map it to the correct tool. This is a simple space where only two tools are available, but if it works now, it can work when there are thousands of tools. And third, we want to make sure that it's flexible enough, because that particular tool that I've defined, it needs about 6 or 7 arguments, but I'm providing 3 or 4 arguments in here. So I'm expecting the agent to be smart enough to know that if the argument has not been provided, so I need to assume something typical. And that's what Mike was emphasizing on one of the main benefits that the agentic workflow is going to provide for the enterprises. So now let's submit that and let's run that. And so basically there is a show progress, which basically which shows you the steps it's going to take to get to the final answer. And that's also pretty cool part that we will see. It doesn't give error all the time. I'm glad that it did, because then I can show you something cool. So what it did was it basically used the RAG, the retrieval augmented generation, found the equation. And this is the equation. So I can quickly go and check. It's from the B1 axial soil spring from ALA. I know that this is correct, but just to show you, I'm gonna show you that search for axial soil springs, and we'll see it's under the section B1, and this is the equation that's been returned correctly, and it provides these are the variables. And then it says that for this particular case that we defined, this is the value, and I've already have an Excel sheet and I've calculated that, and this is 90.41. This is also correct. So not only calculated that, it basically correctly mapped each part of the problem to the specific tool. And it was also able to assume some arguments which were not provided in order to yield to the final answer. But how do we know what it did? So we have no idea what was happening under the hood. This is the cool part, because we do have access to what was going on under the hood. You can basically see every step that the React agent go through in order to get the final answer. Each one of those A to B, B to C, that's pretty transparent, and you can see that. So first it says, First it says to address the first part of the question, it already has broken down the question into two parts. I need to refer to the ALA design guideline to explain how to calculate the maximum axial soil spring force on the buried pipeline. For the second part, I will use the axial soil force calculator. So you can see that it's not using its pre-trained knowledge, because, if you ask ChatGPT, it uses the pre-trained knowledge in most cases. But in here, it is specifically only using the tools to perform the calculation, because in the first question, it already has the equation. So it can simply use its knowledge to answer to the query for the second part, but it's not. It's effectively using, for the second part, even for the calculation, it's using the axial soil force calculator tool. And that's the beauty of that. And yeah, this is for the first part. It says that I'm going to use this, which is like a RAG tool that we have defined. The observation would be what's been returned by the execution of this tool, which is this equation. And these are basically the parameters. And also says that where the information has been retrieved from, which is the section B1, axial soil springs. So obviously, this is just a demo, but in a production level application, you can provide a lot of metadata. So like the page number, et cetera, or the equation number, but this is just to show the capabilities. And then it says that now that I have the equation for calculating the maximum axial soil force, I can proceed to calculate that using the axial soil force calculator tool. So this is the tool that it's using. And so again, another smart thing is that not only it can assume the values that are missing, it can also, it knows that that tool doesn't need inches, it needs meter. So it knows that it has to convert that for consistency. So that's another flexibility that you get out of agent. In like a traditional logic, it's going to throw an error again in here, and then the system is going to break. So again, it's going to assume like these parameters that's not been provided, and these are like a typical value that's been trained on. This is where it's using its knowledge and its training information, which it has to use to provide that flexibility for us. And then it basically runs this. And another cool part, so it throws an error because for some reason it had only 4 arguments, but it didn't pass all the 7 arguments. And it says that, so missing 7 required positional argument, and then it tries again. I need to provide all the required. So it learns if it makes a mistake, and it corrects itself, all the required parameters to the axial soil force calculator tool. And then I will convert pipe diameter from inches to meter, and then it's converting that, and these are the variables, and then run that again, and this time it get the result. So basically in this demo, the goal, and that's basically the final answer. So I've successfully done everything, and this is the response that's going to be returned to the user. So in this demo, the goal was to effectively showcase the majority of the advantages and the benefits that Mike went through in the first half of the session. And as you see, like using React Agentic Workflow provides all those benefits. I know we are getting close to the end of the session, so I'm not going to waste any more time, and let's get into the Q&A. So I see that you might answer the majority of them. Would you like? I'm not sure if. I mean, probably it's better just to go through all of them. So the first one, is it going to be the RAG to extract? That I think that's already been answered. So we have the RAG just to go and parse the document. So LLMs are deterministic, so they output based on what they were trained on. Is there any possibility if the agent could not do something new using RAG, or for example? So so effectively, the agents would be able to do anything that we wanted them to do based on the tools that we make it available to them. But in terms of being deterministic, so that's a little bit of like something we can discuss about. But in terms of like the new capabilities, these based on the tools that we identify for them. So what do you think, Mike? Did I miss anything?
I think that's actually an important point too, is that, of course, if you and I think Farhad mentioned this as well, if you were just to ask a question like this, like one of an engineering problem or a mathematical problem, as most folks on the call, I imagine know, the LLMs can get tripped up pretty easily trying to answer questions that involve equations or other sorts of math. Now, obviously, the organizations that create these things are working on those sorts of challenges. But really what you want to have happen is it's this sort of blend between the probabilistic, if you will, nature of the large language models, which allows the interpretation that you're seeing that Farhad, I think, demonstrated quite effectively here, of the human intent and the human ask. I'm asking this system to perform a function for me. The powerful piece of that is now you don't need to provide all these different things. You don't need to fill in complicated forms. You don't need to do all that stuff. You have the person who's asking the request can put that in a very human way. You don't want the LLM to kind of go nuts trying to figure out how to answer this itself, though. A better way of doing this is to have, the equations that actually govern the various aspects of the pipeline, in this case, design world, mapped out. So then they can become testable. What sort of things the inputs and outputs of those things need to be to get the right answers out of them. But the LLM, the way we harness that is to do exactly the sorts of things that Farhad was showing here. It can do unit conversions. It can figure out the sequence that it needs to go through to, in terms of which tools to use to solve the problem, and so on. So it gives you the best of both worlds in terms of the flexibility around how to approach solving a problem. And as you saw here, this was really cool because the agent actually was able to correct itself. So if something changes in the context of the way, either the way the person asks a question, they ask it differently, and so on, from a developer standpoint, you don't need to sit down and try and figure out all the different possible ways a person could ask a question, what units they might use, and have to cover all of those use cases. The LLM can handle that piece, but you, as a developer, you go in and you just make sure the deterministic pieces are lined up in the way that they need to be to make sure the equations are reliable. So it's quite a powerful way of handling all of this.
Great. Awesome. Thank you, Mike. I appreciate it for the detailed response. And then the next one is, I try to go quickly. Just curious, Anthropic Claude 3.5 Sonnet release introduced the computer use yesterday. Is that part of the agentic AI approach, or that falls under different category? So I can probably answer that, and then Mike, please jump in. That's an advanced application of agentic workflow. So that actually also has the human in the loop part, which is pretty interesting, because what it does is that you can ask the agent to do something, and it does that, and then it returns some result for you, and then you can correct that, and it's more like an interaction between the human and the agent. And yeah, that would be like an advanced agentic workflow, and that's pretty interesting. What do you think, Mike?
Yeah, I think this is another area that there's a lot of innovation happening in that space too, and I think it gets into a bit to the next question I see from Mike Rustle there, where
Sure.
Depending on, and I think that actually I'll go back to the example that I was using about the vacation booking. That's a spot where, of course, it's not an engineering example like this, but in the context of even a simple thing like that, if I'm trying to book a vacation and one of my project managers goes, "Hey, I need that person around for this, this particular meeting or something," they could instruct the agent to say, "Hey," the agent comes in and goes, "Hey, this person's trying to book a vacation." The PM could go, "Oh, wait a second, that they need to be around." The agent could then report back to me and say, "Oh, by the way, project manager for project Y, they're saying that, they need you around for this. What do you want to do?" And then I can give the agent instructions. It's like, "No, I have to go away because of this reason," or "No, that's fine." And then the agent could then try and find another spot where a vacation might work. It's this type of a back and forth that could happen. And Farhad, have you seen the question that Mike has asked there?
Yeah. I can also go through that the last minute. So have you looked at the sensitivity of the output based on the phrasing? Could it be used by a non-expert, or would an expert be required because of the domain-specific wording? So I can get that, and again, Mike, you jump in. So this specific demo was in the pipeline engineering domain, and it's expected that a person who's going to interact with that, who has some limited knowledge about the pipeline engineering. So it's expected that what it does, it acts as a subject matter expert, and it facilitate and augment the workflow and improve the productivity of a junior pipeline engineer who wants to get into the field and who wants to realize so many things. Instead of him need to go through all the documents and understand everything, or need to reach out to a subject matter expert or senior pipeline engineer from time to time. So what this application is going to provide is going to provide that subject matter expert availability 24/7. But in terms of the phrasing and how sensitive it would be to the phrase, so it kind of depends on the domain. When it comes to the design guideline, if we change one word, it could significantly change basically the section of the guideline where it needs to go. For instance, if we are talking about, let's say, the thermal expansion or the axial force on the pipeline, and if we use the word combined, probably in that case, it needs to also account for the circumferential stress or the stress that's coming from the internal pressure as well. And that totally changes the section that the agent should look for. So in this context, it would be sensitive. to the query, but we can provide some human in the loop functionality in it so that it basically agent says that, okay, this is my understanding. And then the human says, okay, so your understanding is correct, or it provides some clarification that, okay, so this is not correct, so you need to do this. And that's how we can also tackle this sensitivity. Or we can also, there are some other strategies to tackle that as well. So, Mike, any last few words?
No, I think that hopefully covered the answer pretty well. But I think, yeah, it'll be this balance between, certainly I wouldn't want to see an over-reliance on. I think the intent here is not to look at replacing people in the context of these sorts of types of workflows and whatnot. It's really about augmenting people's ability to be more effective in the context of these things. So right now we know a lot of people get kind of stuck moving a lot of data around and translating things back and forth so that we can get answers out of these machines. That's not a super effective use of time. A better one is having the machines kind of handle the movement of the data, the translation of the data, filling in parameters, all this type of stuff that has to happen in the context of working across different system boundaries. These AI type things are becoming quite good at that. The domain knowledge and the expertise and making sure that the machines, if this thing comes back with an answer, and again, it still would take somebody who understands the engineering domain, well enough to say, yes, this answer makes sense in the context is the key thing, the context that it's being applied in. So I think it's an augmentation tool. Again, it's not a replacement tool in the sense of the way that this sort of thing is strategy for applying these types of patterns in the enterprise.
Yep, I appreciate it, Mike. So I see that we are 3 minutes over the time. Thank you very much, everybody. If there is any more questions, feel free to reach out to us and we will get back to you. But thanks again for attending another session, and we will see you next month with another interesting application of Agentic AI.
Thanks. Yeah, this is exciting stuff. So thank you for taking the time to join us.
Appreciate it. Bye.